just that. In particular, we are going to view these two important subjects that revolutionized the entire physics world in the early part of the 20th century. And we are going to view these subjects through the lenses of mathematics and especially mathematical tools that are needed to properly understand and fully grasp the meaning, the significance behind these two fundamental subjects. Of course, you need to have some background in calculus, multivariable calculus, especially the divergence theorem. You must know how to use vectors, matrices, matrix multiplication. Not just everything about algebra, but just matrix multiplication, determinants, how to compute determinants. So this is not a basic course, of course, because when you deal with these subjects, especially subjects that deal with modern physics, of course they cannot be basic courses if you're dealing with them in a somewhat rigorous way or in a somewhat technical way. So if you want to use mathematical tools, you need to have some background in calculus and multivariable calculus. Plus, of course, something about classical, some knowledge, some prerequisite knowledge about classical physics may be helpful. So it is not mandatory for you to have a perfect understanding of classical physics, but it would be better if you knew something about Newton's laws and the gravitational attraction law, because this would help you appreciate much more in detail the contents of this course and the lectures that are proposed here. Because otherwise, of course, you can still understand if you have the mathematical tools, but you cannot probably deeply appreciate everything that is explained here, because there is also something that is related to historical aspects. So in here, we are not just having a rigorous approach, but we are having something similar to a historical approach. So how things unfolded progressively in science, and especially in this case in physics. So this is not just an explanation, a very rigorous explanation that doesn't take into account any historical aspect, but we are going to take into account historical aspects as well. And what else? Okay, we are going to study thoroughly tensors in this course, so you don't have to have any prerequisite knowledge about that subject, tensors. And we are also going to study some and introduce and explain Lagrangian mechanics, so how to use the Lagrangian, how to construct a Lagrangian, the Hamiltonian and the action principle. We are going to derive that all that from classical physics. So this is not the standard way. Usually in physics you start from Lagrangian mechanics when you want to explain special and general relativity and also quantum mechanics. So you take that as some kind of fact, so as some kind of axiom. You start from there, and then you build the entire theory in physics. But in this case, we are going to develop the intuition. So we need to start from classical physics and Newton laws, and then we are going to derive Lagrangian mechanics. Of course, we are not going to use a super abstract rigor, because I prefer intuition over rigor in this case. But in my opinion, we are going to derive the concepts of Lagrangian mechanics, so the Lagrangian, the action principle, all starting from classical physics. So I think that this is it for the introduction, and I hope that you will take, of course, you will take part in the course and enjoy.